Okay, so anti-differentiation, the first 3 examples, we're going to work through deriving it, and then we're just going to like undo that. Okay, so this is just going to be basic anti-differentiation. Okay, so we're going to undo basic rule. So for question number 1, what is the derivative of x cubed? 3x squared. Okay, for number 2, what is the derivative of x cubed minus 10?
I got this one.
3x squared. Okay, and then for number 3, 3x squared. So do you kind of see where they're going with this? Like the purpose of them? All the answers are the same. And the like big kicker on here is that when you derive a constant, what happens? It disappears. It turns into 0. Okay, so we kind of have to remember that when we go the other way. When we anti-differentiate, we have to assume that there could have been a constant. Okay, so when we take the antiderivative of 3x squared, the original function is going to be x cubed plus c. Okay, so the letter c is always going to represent some constant. Okay, so here is a new symbol for some of you. You guys see this like curly, kind of looks like a really skinny tall S. Yep, that means integral. So you would say this as the integral of 3x squared. Okay, so the integral of 3x squared is x to the 3rd plus c. Okay. The expression is called an integrand. Okay, so you can call it an integral, an integrand. dx indicates that you are integrating in terms of x, but does not affect the integration process. Remember that c is always representing your some constant. Okay, so here's your rules. Okay, so the power rule, which is undoing the basic power rule of differentiation, basically all that is happening. So like when you derive something, you take the exponent and you multiply it by the number in front. Okay, so to undo multiplication, we're going to divide by it. Okay, so that's why we have the n plus 1 that's being divided. Okay, so that goes in the bottom. And then notice that our exponent now is now going to become 1 bigger. Okay, is everybody okay with this definition right here? Okay, so we're going to add 1 to the exponent, whatever it happens to be, and then we're going to divide by it. Okay, notice the n cannot be -1. Okay. The constant rule, we just know that if you integrate some constant, so notice they use a different letter for this one. The integral of, let's just say there was a 2. What is the integral of 2? 2x, right? So you just add an x to everything. That's basically what you're doing. Okay. Scalar multiple rule. So if you have some constant in front, so that was basically the same as what we had for our example up here. Okay, so if we have a scalar in the front of our x, okay, so like our scalar in front of this would be a 3. Okay, that's your k. You're just going to add 1 to your exponent. So my x squared is going to turn into a 3, and then we would divide by it. So 3 divided by 3 is how we get a 1 in the front of it. Okay, and then of course the sum rule, you just integrate each term just like we did with differentiation. All right, let's give it a go. So for question number 4, we're going to integrate. So we will start by adding 1 to the exponent and then dividing by it. So my current exponent is 3, so it's going to turn to 4. Okay, so we can write it as x to the fourth divided by 4 plus c, or you can write it as 1/4 x to the fourth plus c. Okay, so both of these are equivalent. One is not simpler than the other. So whatever feels more comfortable to you, you can do. I'm just going to circle the bottom one because it's literally on the bottom. All right, number 5. What is the integral of 2? 2x, very good. So remember, all you're doing is you're adding an x to every single term. What do I have to put at the end? Plus c. Okay, so every single time you integrate, you always need to have a plus c. And I can guarantee on the test that somebody in here is going to forget the plus c at the end and lose a half a point. No, not every question, just a half a point.
Half a point.
It might be a lot of points in the end, though. Okay, so make sure you go back and say, wait, did I integrate? Okay, I need a plus c here. Okay. All right, what is the integral of t to the fourth? So what is my exponent? Okay, so is everybody saying 1/5 t to the fifth? Plus integral of 2 is 2t plus c. Okay, and notice that they did switch up the variables. Okay, and you can see that notation. So this dt at the end of it is literally notation. Okay, it does not mean that it's part of the equation. It's the notation, like our function was in terms of t. Okay, and notice they do put it in parentheses, so the function is in parentheses between the integral and the notation piece. Okay, it's not always going to be in parentheses, just so you know. All right, number 7. Okay, so number 7. Same thing, we're just going to integrate each term. Okay, so what is the integral of 2y squared? Okay, so if you're adding 1 to the exponent, what is our new exponent going to be? 3. So what are we also going to divide by? 3. And notice this one has a 2 in the front. So it's going to be good. 2/3 y to the third. Okay. What about 4y?
2y squared.
Nice. Is everybody able to jump like that and go to 2? Because since our exponent currently is 1, we're adding 1. So we're going to have, I'll just write it, 4 over 2y squared. Okay. You'll get better at simplifying it. The integral of 1. Close, y in this case, and then at the end we need a plus c. Okay, so you do always need to simplify when possible. We should definitely have a plus 2y squared plus y plus c. All right, now question number 8 is slightly more complicated because the original function needs to be rewritten first. Okay, so we're going to start by rewriting the integral before we take it. Okay, so what is 3 over x squared the same as?
3x to the negative squared.
3x to the negative squared, negative 2, yeah. Okay, what is the second one if I have a square root? Square root is the same as to the 1/2. Okay, so if it's in the bottom and I want to pull it up, what is it now going to become?
Negative 1/2.
Negative 1/2, good. Okay, so I'm going to rewrite it just like I would do differentiation, and now I'm going to integrate it.
Wait, wouldn't it be minus x?
Oh, minus, thank you. Yes, it surely would. Minus, thank you. All right, so if I integrate 3x to the negative third, remember that I'm adding 1 to the exponent. So my current exponent is negative 2. If I add 1 to negative 2, what would I get? Make sure you add 1. Negative 1. So it's going to be 3 over negative 1, yes, to the negative 1. And then, yep, I'll simplify it here in a second. My exponent on the second term is negative 1/2. If I add 1 to negative 1/2, what's my new exponent? 1/2. So if I divide by 1/2, what is that the same as?
Multiply by 2.
Multiplying by 2. Good. So I'm going to multiply it by 2. And then don't forget your plus c. Okay, so now how would I rewrite my first term? What is that the same as? Good. Negative 3 over x. And then my second term looks good. And my plus c. Okay. All right, number 9. Okay, so number 9 is given to us as a quotient. Do we know a quotient integration rule? No. And in fact, there is not one. That's not even a thing. So for us to integrate this, we must simplify first.
Should zero out the train.
I think it doesn't exist.
Okay, so remember that when I separate this, this is the same as x to the 1/2 over x squared plus 1 over x squared. Okay, so I'm separating it. Okay, and then if I simplify this, if I have x to the 1/2 over x squared, what is my exponent? X to the 1/2 over x squared. What do I do with those exponents? Subtract them. So what's 1/2 minus 2? Negative 1.5. I'm going to call that negative 3/2. Okay, and on my second term, if I pull my x squared up, what is my new exponent? Negative 2. Good. Okay, so now I can integrate this. Okay, the integral of x to the negative 3/2, I'm adding 1 to negative 3/2, so what's my new exponent? Negative 1/2. So if I divide by negative 1/2, what is that the same as? Good, multiplying by negative 2. So I'm going to have negative 2x to the negative 1/2. On my second term, my current exponent is negative 2, so if I add 1 to negative 2, negative 1. So I'm going to have negative x to the negative 1 plus c. Okay, so then I have to simplify this and write this correctly. All of my terms with negative exponents are going to get pushed down. So what's my first term going to be?
Negative 2 over.
Good. And you can say a square root of x or x to the 1/2. Both are simplified correctly. I don't know why I just always leave things in the exponential form. What's my second term going to be? 1 over x plus 1. Not too bad? All right, so the second half of this is now being able to find the c. Okay, so for us to find the c, we need additional information. Okay, so notice in example number 10, they give us an f of 1 equals 3/2. So essentially, they're giving us a what? A point. Okay, so they're giving us a point so that we can solve and find the c value. Okay, so we can find the original function. So I'm going to start by integrating. So what is the integral of x to the negative 3rd? Okay, so it's going to be 1 over negative 2 x to the negative 2 plus c. Okay, so if I rewrite that correctly, that would really be the same as 1 over negative 2x squared plus c. Okay, so now what I'm going to do is I'm going to plug in my point as an x and a y. So remember, which value is the x here? The 1. So 1 is my x, 3/2 is my y, so I'm plugging that in. So 3/2 is equal to 1 over negative 2 times 1 squared plus c. So if I simplify the bottom, I would have 1 over negative 2. And to solve for c, what would you do? Add the 1/2. So what is 3/2 plus 1/2? Okay, 4/2, which is 2. Good. So if my c value is 2, I can now say that my function is, I'm going to say negative 1 over 2x squared plus 2. Yes. Yep.
You added up.
All right, where are you looking at? Are you looking at this right here?
Yeah.
Yep. So this is a negative 1/2. So if I have the negative on the top or bottom,
You're
it's
throwing it on
the
the other
same.
side.
Yep, I'm adding it to the other side. Yep. You're good. Handicapped? No, you're not. All right. Check out question number 11. This is an interesting question. Okay, so you really have to understand what this is asking and the notation behind it for you to do this correctly. Okay, what does it mean when it says d dx? What is this notation right here? That is derivative. Okay, so it says the derivative of the integral of this piece of dx. So what happens if you derive an integral? You like get right back to where you started, right? So when you have the same stuff, this is just literally going to equal 5 square roots of x minus 1 over x squared. Okay, so they will try to kind of trick you with that notation so that you understand what you're doing. d dx is deriving. You got the integral. They basically cancel each other out, and you're left with what it's of. Okay. Okay, so we're almost done, guys. We got this. All right, so last piece, we're working with position, velocity, and acceleration. Okay, so what they're going to do is they're going to start with the acceleration, and now we're going to integrate so that you can get to velocity and then integrate to get to position. Okay, so now we can go both ways. Okay, so for question number 12, they say that the acceleration is 4t minus 3. Okay, they give us some points. They give us a point at velocity, and they give us a point at the position. Okay, so for question A, we're trying to find the velocity equation. So how do I go from acceleration to velocity? You integrate, right? So to go from acceleration to velocity, I'm going to integrate. So what is the integral of 4t? See if you can jump on that one. Okay, is everybody okay with 2t squared? Okay, so 2t squared, and the integral of negative 3 minus 3t, and then what do I have to put at the end? Plus c. Good. Okay, so now I'm going to find the c by using the velocity point. So what's my velocity point? 1, 6. Okay, so my 6 is going to be my velocity, my 1 is my time. So I'm going to plug that in. So I have 6 equals 2 times 1 squared minus 3 times 1 plus c. So if we simplify this, my first term is 2 minus 3 plus c. So 2 minus 3 is negative 1. If I add negative 1 to 6, my c value is 7. Whoa. Okay, so that means my velocity equation is 2t squared minus 3t plus 7. Okay, so now we can go one step further and go to the position. So to find position, what am I going to do to the velocity equation? Integrate it. Do it again. Okay, so what is the integral of 2t squared? 2/3 t cubed. What is the integral of 3t? 3/2 t squared. Sorry, that glitched. What is the integral of 7? 7t, and then at the end I have a plus c. Okay, so last step here, I'm going to plug my point 2, 5 in. So 5 is going to be my position. I'm looking at the t value of 2. Seven times 2 plus c. So let's see, we get 2 cubed is 8. 8 times 2 is 16/3. Then I get 2 squared is 4. 4 divided by 2 is 2. 2 times 3 is 6 plus 14.
Staff and students, this is Assistant Principal Shannon Smith. We are now in a shelter-in-place. This is a classroom, shelter-in-place. Interquest Detection Canines of Montana are in the building. Staff, please keep students in your classroom. If a student needs to leave the classroom, please radio for an escort. Any teacher on prep at this time or with a student teacher, please report to the office. Also, all teachers, please turn on your radios at this time. Thank you.
Alright, so making this quick on you, the c value is negative 25/3. I typed it in the calculator. So my equation is going to be minus 3/2 t squared plus 7t minus 25/3. All right. Everybody okay with that for me jumping on that C? Okay. All right. So this last little piece is just proving the equation of position for a falling object. Okay. So I'm sure you all have wondered, like, how did they know the equation for position? I'm sure you wondered that when you're in physics class. I know Jaden did. So, well, let me tell you, Jaden. I'll just explain that we know for a fact that things fall on Earth with an acceleration due to gravity at approximately negative 32 feet per second. Squared. Thank you. Okay, so that is telling us that we have an acceleration. Okay, so you might say, okay, well then my acceleration of t is equal to negative 32. Okay, so we can find the velocity equation by integrating it. Okay, so what is the integral of negative 32? Negative 32. Wow, that's not a 2. 32t. And then plus c. So do you see that notation? Shh. So instead of saying plus c, they say use your plus c as v sub o as initial velocity. So I'm going to say plus initial velocity. So that's your c value. Okay. And then for me to now go to position, I can integrate my velocity. Okay. So what is the integral of negative 32t? Negative 32 over 2 t squared plus, what is the integral of v sub o, assuming it's some constant value? V sub o t. V sub o t, and then we have our plus c, which in this case they say use s sub o for your initial position. So 32 divided by 2 makes negative 16. Is anybody in physics this year?
I was in it last year. Gary and Jaden. Yeah, me and Jaden didn't tell you anything about physics. Yeah.
Oh, is this the equation that you've used for position of a falling object?
Without the initial, yes.
Without initial?
Like the volume or the velocity at 0. Like we don't use that. In our physics, at least, you don't use that.
Oh,
From what I
interesting.
remember, I honestly don't.
I haven't seen that person yet.
Interesting. Didn't you guys do like parachutes and stuff? You must have used something different. I don't know. Yeah. Oh yeah. I remember there was a sheet. Yeah, because she used different variables.
Jackson, that'd be right.